Let me start the recording.
Is on.
In Room, the design is in a way that you describe the structure of your database, and then it handles everything. It handles querying the database, inserting new data to the database, and updating the database. And in fact, it's very effective even for basic usages and even for basic students of Android, not only for professional users. Sorry, just 5 seconds. I'm back.
Okay, can you share your screen?
Yes, sure. I haven't started Android Studio yet. Let me share the screen. That's better. And our application is the phone book. We have 2 more sessions. This session is about the Room database, and the next session will be our final session in the course. It will be about publishing the application. And once we finish this lecture, I will tell you some information about how to prepare for the next lecture, because you need to do some stuff so that we effectively go forward in the next lecture. So after this lecture, I end the recording, and then we will have a short talk on how to prepare for it.
Okay. Okay.
All right. We have our application app. As you remember, we added a recycler view, and we added an adapter for our recycler view in the previous lecture. And now we will make our application even better and even more modern and more effective by adding the Room database support. Before our application can support Room, we need to add the libraries that are related to Room and add its support to our application. And since it's not a single library, we need to add a couple of them. For that purpose, we go to d.android.com and jetpack/jetpack. Note that Jetpack is a group of libraries that help us write better applications in Android. Since our course was only a basic course, we didn't touch upon these architecture components or libraries. The only one that we will discuss in this course is Room. Of course, there was also view binding that we touched upon a little bit. So let me find Room. Libraries. We have a lot of libraries in this package, but we only need Room. That's it. I select Room, and in this page, we see the dependencies that we need to add to our application. I copy the whole section between the opening and closing braces and go to my build.gradle file in the app module and paste it here. Then press sync now. The project may be using a version of Untitled that does not contain the method test compile. Plugin to 401. Yeah, there's an Android Studio warning that says your Gradle plugin version is low. So let's make sure that it's correct. 401. It's 401. So this is not correct. Gradle using a version of Gradle that does not contain the method. If I'm missing Gradle plugin. No, I think the app is a little bit confused.
Yeah.
We have one app here. Why is that? Try again. Get status. Nothing here. Event log. Not found. Kept. We can find better information on how to add room on the developer's guide page or d.android.com/guide. And there's a section on the left, app data and files, under which we can find the database section. Save data in a local database. First, we need to know how it works. After adding these requirements to our build.gradle file. Kotlin. Yeah, the Kotlin plugin is available and already applied to our application, so there's no problem in that. We should be able to support capt, because capt is the annotation processor for Kotlin. This is kind of weird. 401. Let us see if we can run it the way it is. Seems like there's some change in our source code. room Android. Do you still have my voice?
Yeah.
Okay. 1 minute, I lost my own voice. And that's because of the emulator, I guess. Room Android Code Lab. There are some tips here. Yeah, Kotlin capped, that unfortunately are not written in this guide. Kotlin capped. We need to make sure that we apply Kotlin capped too. Now I think the problem will be solved. This is annotation processor Kotlin plugin. We add that, and also we need to add this part to the Android section in our build file. Yes, the build is successful. We think to add the other option too. This code lab that you see here uses several other technologies. You see that it has a lot more dependencies added to the build.gradle file. But we are not going to make our application that complicated. We are going to only use room, and that's enough for our lecture. So back to my code. Now I'm going to tell you what we need, what components we need in our application in order to add the support for room database. As you can see in the guide here, in order to have a database system using room architecture, we need several types of objects. One of them is the entity. And what is the entity? You remember that in our database, in our SQLite database, we created a table called, do you remember its name?
No. What was it?
It was person. It was
Person, yeah.
responsible for saving the information of our contacts. Every person, like a real person in the real world, has some information associated with it. And every table holds information about a person. So we can say that each table is an entity. We can save it as an entity in our database. So entity is one of the things that we need for our database. Another thing that we need is the database itself to connect to the database fields, database tables, and manage them. And then we have the rest of our application that makes a connection to the database and asks the database to do database operations. Another thing in the database architecture itself is something called DAO, or Data Access Object. And this is something that is responsible for running the queries and doing the operations that we expect from a database table for us. For example, if we have a contact entity, we have also a contact DAO, or data access object, that is responsible for updating that contact to selecting up contacts from our database, adding to those contacts, and operations like that. So we will define 3 different classes. One of them is entity, another is the database class, and the other is our DAO. These are the least number or the as few as possible number of classes that we will need in our application. Back to my code. Let's define our entity. New Kotlin file or class. And I select the class category, and I'm going to create a contact entity. I need to precede this class definition with an annotation called entity, like this. And once I import that entity class from the AndroidX.room package, I need to specify the table name for it, the table that will be associated with this contact entity. So table name. What was the name of our table in the database? Do you remember? Person.
Person, yeah.
Table name. And what members does the class have? A person had several different columns, a person table. It had, for example, full name. It had phone number. It had, if I open the contact class, full name, phone, location, ID. In fact, I can remove this contact entity and use the class that I already have here, the contact class that I already have here as my contact entity. So I just remove this file and prefix the class that I already have for contact with entity. Import entity and table name. Specify the table name, which is person. Also for individual members of the class or for columns of the table in the database, I can precede them with an annotation that specifies the responsibility of that column, the type of that column. For example, for full name, column info, enter column info, and then open the parentheses. Here, for column info, we type exactly the column name that we have used in our database definition, or we plan to use in our database definition. So I can say full name. Name, full name. Because it's a named parameter, we need to specify it. Specify the parameter name. And then the phone number. For phone number, we also add column info. And we know that for this column, the column name was phone. And to make it easier to see the columns, I add a break. Another column info. Location. We also had ID. So column info. Name, ID. And I think since this is primary key, we can use primary key annotation because this ID will be our primary key. Auto-generate. I add auto-generate as true so that it can generate IDs for me and make distinguished rows for this table. Now that I have my contact entity, I can go ahead and create a DAO. And as I said, DAO is responsible for doing database operations. So another class, I create another class, I name it contact DAO. And this is subclass from the DAO class. DAO. This should be abstract, I guess. Abstract class from the DAO class. DAO. And the other one was a data class, because its main responsibility is to hold some data for us. Contact DAO. Yeah, entity, primary key, column info. Sorry, it's an interface. It's not a class. It's an interface. It should be an interface because we don't define them. We just declare them. You see, we only declare the name of the function inside the interface, and we don't add a body for it. So it's an interface. And one of the things that we will do is getting information from the database, getting the list of our contacts. So I add a method getAll, which will return us a list of contacts. And we need to tell it what query to run to do that. So I say query, and then select all from person. In fact, let's make it the same name as our contact entity. Because our entity's name is contact, you see this is contact, let's make the table, rename the table to contact, not person. Contact. And we can also add an insert to insert a new member to our contact table. Fun, insert, or add contact. And this will receive contact and add it entity. Yeah. And if I make this a vararg, this means variable arguments. If I specify vararg in front of contact, it means that it can be one member or it can be several contacts. We can pass into this method. So for now, it's enough. Now our DAO is able to read from the database, these information from the table and also add new members to our table. One thing left is creating our database table. I create another Kotlin file and name it contact, or let's call it appdb, because there are some other tables in the future that probably we will want to add, and it's not just for contact. AppDB is application DB, and this is an abstract class. Is a child of room database. And we require context for it in order to initialize the database. Since I want to make context a member of this class, I specify val, which means make this a member of the class. All right. And the most important thing when defining your database is adding this annotation before the class name, before the class definition, because Room works based on these annotations most of the time. I import database, and then there are parameters like which classes exist in our database. Currently, only one class or entity exists in our database, and it's contact. So I create an array, entities, array of our class name, which is contact class. No, it's just a class. Doesn't accept it. User class. And also here it requires or recommends using the array constant array operator to pass in this group of entities or tables. And the next parameter is our version. Let's see. You remember we had something called version when we defined database, SQLite database. And when we wanted to clear the cache of previous database, we incremented that number.
Yeah.
We start from number 1. And a method that is necessary inside the body of this class is an abstract method called a name that we choose. We don't have to give it a specific name, but it must be abstract. Abstract fun, user DAO, and it must return a DAO. As you can see, after creating, you get an instance of the created database using the following code. Abstract fun contact DAO, and it returns this type, contact DAO. And that's it. We define these 3 components in our application, and now the database will be created based on these descriptions that we added. A table will be created named contact with these fields: full name, phone, location, and ID, and we can access the database inside our application. We need to go to main activity where we worked with the database. And we need a database field. we already had a database member of this class that we defined it as DB. We named it DB, and it was of the type SQLite database. But it has to be of the new type that we defined, which means appdb. So I define another field late in it where I name it appdb and specify its type as appdb. Let's import it. Now, in order to use it in the onCreate method, I need to initialize it. And note that initializing a room database is a little bit expensive. So try to initialize it only once in your application. And later, we discuss a technique that allows you to make sure that you only get one instance of your database rather than initializing a couple of times. Because when you have more tables in your database, it will become heavier and make initializing them more expensive and time consuming. The way I initialize it is this way: appdb and room database builder sounds like room room.database builder appdb room.database builder. We need a context for it. What is the context? Application context. The second parameter is the database class that we defined for our database, and it is called appdb. Appdb the : class .java. And the last one is the name of the database file that will be created in our phone. So let's name it contacts, contacts.db. As you can see, we have a warning here. Build. Once we call build, it returns an object of the type appdb, so we will have no problem here. But we still have some issue. If we run or try to run this application, it will crash and it will return an error. And I will tell you why in a little bit. You remember I told you that room is a little bit expensive because it has a lot of abstractions. And as our application size grows and we add more tables, it becomes more expensive, and therefore it might add some lag to our application, and our application might fail to respond in time and create a bad user experience, which nobody likes, right?
Yeah, I remember.
Therefore, this library has created something. Final class constructor cannot be applied to given types. Should format class appdb. Let's see our database definition, database, abstract class, appdb, okay. Abstract font, user DAO. There doesn't seem to be any problem here. Let's run it again, build it again. Sometimes this happens. Required context, no arguments. And if you notice, this file is inside this path. If I open it, it's under generated. This means that while we build our application, this file is generated for us. So if I clear or clean my application, this file will be recreated again. So let's clean it. Sometimes this helps solve some issues with our application. And we will see if it helps us in this case. Interface DAO, entity data class. Constructor appdb. Appdb. I understand. We passed in a context here. We passed in a context for our class definition, but it doesn't accept parameter in the constructor. As you can see, constructor appdb, the way that room expects our class to be doesn't expect any context. Cannot be applied to given types. All right. Now, if we run our application, this error will not surface anymore, but still there is another error that we will have. And I will talk about it in a little bit. It's weird. We are initializing our database here. Okay, we are initializing the database, okay, but we didn't access data, so it's not a problem. If we try to access some data here, we'll have a problem. Yeah. And that's a limitation that the room restricts us to be bound to. And why is it so? Because room doesn't allow you to do database operations in the main thread of your application. This is the main UI thread of your application. And here you are not allowed to do that. If, for example, I add some new contacts, let's say appdb, and I say appdb contact DAO, and in the contact DAO, we had one method that we defined to add contacts, named contact, add contact, and I create a new contact with an example contact. We had several parameters like full name, phone, location. So I entered this information, John Doe. This is our phone, location, something like this, and ID. Since ID is on auto generate, we will not have any problem creating it. Since now this code should do that for us, should do the operation for us. No value passed for parameter ID. ID is on auto generate. Let's pass in as an ID as well. It crashed, you see?
Yeah.
Like cat. I go to the error section.
Hi, you got disconnected, Mr. Hak. Okay, okay.
Do you hear me? Hi. Do you hear me?
Hi, I hear you.
Good. Let's just rename this file because I don't want to make this
I don't have your screen.
I don't want to make it complicated. I'm going to share it now. See, let's rename it something like contacts1. Because database migration is a little bit beyond the scope of this lecture. Just want to access the database and save some information. Yes, this is the error that I expected to surface, and now you see that it's showing up here. Java.lang unable to start activity component. Why? Because cannot access database on the main thread, since it may potentially lock the UI for a long period of time. So what do we do to deal with this error? We cannot access our database in the main thread. So there's a technique that I tell you to deal with that. And that's making connection to your database and doing database operations inside a global scope. Global scope, if it is added to my, GlobalScope.launch. This is using a technology called Kotlin coroutines that allows us to do some operations behind the scenes, not in the main thread, in some background thread, and then return the result. And while we are doing that, while we are processing some information in the background, our application doesn't freeze and we can do other stuff. So I remove this part into the braces, between the opening and closing braces of this GlobalScope.launch function. And if I run the app again, I should have no problem like this again. But note that after that, we need to make sure that we do all our database operations in a coroutine scope like this. Yes, our application didn't crash this time.
Yeah.
So what do we do to add items to our database? How do we add items to our database using this technique and using the room database? Note that we have a section in our main activity in which we launch another activity called add contact activity. That opens up another activity, allows the user to enter a new contact information, and then we got back and receive information about that contact via an intent, and then insert them in our database. All we need to do is to find that section. On activity result, this is the section that we received those information and we added them to our database, to our SQLite database. But now we are going to put them in our room database and then update our list. So let's use this information to create a new contact. Val new contact. Val new contact. Contact. What are the fields of the contact? Full name, phone, location, and the ID. What's the problem? Why is this red? Okay, this might be a nullable string. So I go back to contact and make these nullables. All right. And also the ID. Currently, we don't have the ID because we just got them from the user and we don't have an ID for it. So we pass in null so that the room database will create it for us. Or simply just make the ID nullable here. And pass null. Since it's nullable, it accepts null. Then how do I add it to the database? I just create a connection to the database via GlobalScope.launch coroutine, and I call my database appdb and say contact DAO database access object, and then say add contact. Which contact? New contact. All right, it's added, and then I have a method that says updateList. What does updateList do? UpdateList reads all the information from our database and then displays it for us. So all I need to do here is to get that information again via GlobalScope.launch block. I say appdb contact DAO get all. This receives all contacts from the database. I create a list. Val contact list or contacts. Mutable list of, because it's an empty list in the beginning, but we will fill it. What's the type of this list? It's a list of contacts. How do we fill it? We fill it with the contacts that we read from the database. So I say contacts equals get all. Contacts is list of contacts. And what's the problem? Get all cannot. Okay, this should be var. Type mismatch list, mutable list. Cast expression, contact DAO, get all to mutable list contact. Yeah, we can cast it to mutable list in order to be able to assign it to this contacts list. And once we did that, we can use that contact outside the launch coroutine to specify the list of contacts that we will display in our adapter. So, in fact, we already have M contacts. You see, we already have M contacts, and I can use it. So let's just stick to that. I say M contacts. M contacts. If its type matches, it will be all right. Mutable list. Contact. Change it to var, private var. All right. So we read the information. Now we can use it for the adapter of our recycler view. M adapter. M adapter. Yeah, it's already using it. So that's all right. We don't need this part anymore. And we also don't need our cursor because this time we are using the room database. We are moving away from directly working with SQLite. And interestingly, room also is using SQLite technology behind the scenes. It's just making things easier for us. All right. So once we return, we get a new contact we added to the database, and then we update the list. And also in the beginning of our application run, we open the activity and we update the list, which means we read information from the already filled database and display them in our list. What line was expected? Get item ID. Contacts. Return line, but line was expected. Get view. In fact, we don't need this file anymore because this is for the list view that was using the traditional way of creating the list. And it had an ID of type lang, but currently our ID is nullable. So I can just remove and get rid of this file for now. Run the app again. We had a crash. Like cat. What's the crash for? Room cannot verify the data integrity. It looks like you've changed the schema but forgot to update the version. You can simply fix this by increasing the version number. Yes, we changed the version we changed the database a little bit. You remember we changed the type to nullable. So I increased the database version in our appdb file to 2. Run the app again. Again, it's some migration error because we haven't defined a migration policy, and we have to do that in a short while too. But for now, let's just remove the app from the phone because we want to see how it works. Phone book. Do you have my voice, Hanan?
Yeah, I have your voice.
Great. Latent property has not been initialized. Wow, today is full of surprises. Cursor. Yeah, we need to remove the cursor stuff because we are not using the cursor anymore, and I commented out cursor here, so we cannot close a cursor that we have not initialized. So I think the error is now solved. So what is that? Unique constraint failed. Contact ID. Invoke, suspend. Seems like we have inserted something twice. In the beginning, we inserted a user with the ID of 1, and we are doing that again, so it will fail. This is obvious. This was just for testing. So I remove it. All right, our database has nothing to show, but we will add information to it. Though 0 on location 34. Yes, it was added. Another Jane Doe 0. I love the Doe family. Therefore, good. You see, it was not that hard. This room database is easy to get started with, but since it is interrelated with some other libraries, it sometimes makes it tricky, and it has some rules. The rule that, for example, doesn't allow you to do database stuff in your main thread of application. You have to do it in some background thread, as we did in our global scope. Yeah, this one, GlobalScope.launch. Whenever we add database, we did it inside a GlobalScope.launch block. But now I'm going to expand the database class a little bit so that it can do these migrations by itself easily. When we increase the version number, we don't have to go and delete the database or uninstall the application to run the app again. And also, as I said, a room database is a little bit heavy. So each time you initialize it, you take some memory and some other resources, and you are better off to make sure that you don't initialize the database twice or a couple of times. For this purpose, we will use a design pattern called Singleton. Singleton means that we use a mechanism, a technique that allows us to make sure that we create only one instance of a class. We instantiate only one object of a class, because we know that, for example, that class is expensive and creating several copies is not good. So let's create that. To create a single instance of a class, we will have a static field, a field inside that class, a member of that class that points to an instance of it. We call that a static member. We define static members inside companion objects in Kotlin classes. So I define it inside companion object block, and I name it app give me a minute, since we are returning a room database. Yeah, since we want a room database, appdb. Its type is supposed to be appdb. So I name it var instance, and its type is nullable. It's nullable, but of which type? Its type is appdb. All right. We initialize it with null. And then we create a method inside our database class that returns an instance of our database. So I say fun get instance, fun get instance. What type? appdb. And inside this method, also note that this method is static. Every static member has to be inside companion object. Static, something that is static, can be called without creating a new object of that class. For example, when I move this inside companion object, I can say appdb : get instance without creating an object from appdb. So here I say get instance, and first I check to see if this instance is not null. If it's not null, I can return it. I say if instance not equal to null, then return instance. Val, since instance is nullable, Kotlin is very strict on nullable stuff, on nullable types. We put it in.
Can we pause the class for a few minutes?
Sure.
I will be back. I'm sorry. Okay?
Sure, okay.
I'll be right back.
Okay. Temp instance. I put temp instance inside temp instance and return temp instance. I hate this part of initializing it. If it's null, we create a new instance. So let's start with that. I don't want to look up this code. I have to write it myself. If instance is null, then we create a new instance. And then we return it. We also save it as the value of instance.
Okay, I'm sorry. We can continue.
Okay, good. First, let's start with it being null, with instance being null. Because the first time we know that instance is null. If it's null, we need to create a new instance of the database. So I define a new instance like val new instance. And I create it with room database builder. And since it requires a context, I need to pass in the context here as well to the get instance method. So I pass in context, the class name for the database appdb class, class.java, and the name of our database context.db, and build. Okay, it now returns a database of the type appdb, our database. So let's save this new instance as our instance, new instance, new instance, and then return new instance. But what if it was not null? If it was not null, we should return the instance. So return instance. This part is a little bit tricky. Every time I had some issue with that. We have to make sure that we don't return a nullable, and instance is nullable. We have a new instance. All right, we created a new instance. Can we create another member, another variable to hold instance? New instance. We put this value inside the instance. And we save the new instance. What if we make this late init? If we make this late init, var instance appdb, and then here we put instance into our instance. Now we cannot access that non-static member inside our static block, so this doesn't work. So we created a new instance here, we returned the new instance, and we saved this one. But return instance, if the instance is null, create a new instance and we return it. Otherwise, we return instance. There was a technique that it was using to do that. Okay, it returns instance. And says if instance is not null, return instance. If it's null, then create a new instance and return it. Synchronize. Then return it. If it is, then create the database. All right. Field, an instance, and instance. Yeah, it's not that difficult. Return return instance if it is not null. If it is, then create the database. Synchronized. And this synchronized thing might be new to you. A synchronized block means that we are the only thread that is touching this part of the code. No other code is touching this code. We do this to make sure that our database is initialized only by one thread at a time. Val instance, synchronized, we create the new instance, we return it. Object get instance to appdb. If it's not null, return the left side. If it's null, then synchronized this, synchronize context, this part, synchronized. When we pass in a block of code to a method, you see, this looks like a method, right? The synchronized is a method. And we pass in a context, we pass in this, of course, this. When we run synchronized, we often use a lock of this, which means only this class is supposed to manipulate this code, this block of code, and no other part, no other thread. So we lock it with this, and then we pass in this method. You see these lines, we have passed in these lines as a parameter, as the second parameter of this method. When we do that, we call this lambda, which means this part, all of this is lambda. Kotlin recommends that when you have the lambda as the second parameter or as the last parameter of a method, you can move it outside the parentheses like this. You see now it is inside the parentheses, but Kotlin says you can bring it out of the parentheses this way. So now we do the initialization here. We say if instance is not null, return it. And then if it is null, create the database and then return it. So what's the problem here? We have get instance appdb. We are returning appdb, expecting this. Synchronized. Yes. No. Synchronized instance. We don't need the parentheses here. Just do a synchronized call. We make a synchronized call and we return it. But there's also something additional that we need to do for our migration. For database scope, in order not to have to remove the application each time we increase our version number, we add some migration too. We do that before calling build. So I add callback from database callback. Database dot callback. We often add callbacks to initialize the database in the first place. You remember in the previous lecture, in some older lecture that we had about SQLite database, when we created the database, we added some initial information. We had your name, for example, to the database. You remember it?
Yeah, I remember.
This callback is for that, but it's optional. We can remove add callback because we often don't need to add some initial information to it. But migration is important. Migration is important, and add migrations. Since I want to make it destructive, remove the older database, I say add callback. What database callback? No, we don't have a callback. We just want to allow destructive. Fallback to destructive migration. Yes, this is the method that we use. All right. After this change, now we have another method to access the database, get instance. Now we don't have to access the database in our main activity the way we are currently doing. Currently, we are creating it this way. I change it. Now I say appdb.getInstance, and I pass in the context of this application context. Now run the application again. The only part that is a little bit tricky is this part. If you understand what this code does and remember it, you won't have a hard time using room in your application. And as you saw, it's easy to start with, to create a contact entity and create a contact DAO and the database class itself. Yes. So, do you know what it did? When we run the application, since we changed a little bit, we changed the database, it removed the previous database because we allowed it to fall back to destructive migration. Each time we change the database structure, it falls back to destructive migration, and it removes the previous database and starts over. If you want to change this, if you want to overwrite this and do some advanced migration, so for example, you have some important information in your database and you don't want to lose them, you can use migrations, and you can add a migration that you define. And it's not very hard to define it, but it's a little bit advanced and beyond this class for now. But I'm just mentioning that you can do that.
Yeah, so just for now, we're using a fallback destruction. So
fallback to destructive.
It clears the info that we put every time we reset the program, right?
Yeah, every time that you changed the database structure, every time that, for example, you change this file name, the database file name, or you change this version number.
Yeah.
You see? Or change the structure of your tables. For example, you change the contact columns. We have a contact entity that has full name. If you, for example, split the columns for full name to 2 columns, it becomes name, first name, and family name. You will have 2 columns for this. In a sense, you have changed the structure of your database. So in order to continue running the application knows to know how to migrate to the new version of your database. We simply destruct the old database, in this case, in our application, and start over with the new structure. So that's why it cleared the database and our list is empty.
Yeah.
So location 1, I think it's North Pole. Oh, what What happened? It didn't save. Jane Doe location 4198. Yeah, it was saved, but the problem was it didn't show them in the first place. Why is that? In our main activity, we return from the other activity. We should get rid of, oh, you see, we have two contact. Yes, we have two database files named contact. You remember our previous database, DB?
Yeah.
You should get rid of it because it was also named contacts. Person. Contact DB helper. Yeah, it is contacts DB, and it has some conflicts with our current setup. We need to get rid of it. I comment out all the parts that deal with it. So after we return from our add contact activity, we need to comment it out. We don't need content values anymore because we're not using SQLite. And we don't need the returning number from DB insert as well. All right. We just save it using the new mechanism, the room database, and update the list. Are there any errors? No errors. Run the app again. Okay. What? What happened? Just removed everything again.
Yeah.
You know what happens? Why it happened? It was most probably because we had two parties touching the same database at the same time. And now it will be solved because room database is the only one that is working with the database. So John Doe 0 something like this. It's weird. Get all update list. It reads from database. Let's remove the old database file. Don't need it. Also remove its imports. But interestingly, we don't have any migration right now.
Yeah.
Installing. Nothing. Some phone number, location. Yeah, it's saved this time.
Yeah.
Yeah, the problem was because of that, seems like. Great. So essentially our application basically works. Oh.
Maybe it's because of the destruction.
But we are not migrating. We are not increasing the version number of our
Oh,
database. It's weird. The database on open and on create. No, we don't need to do anything here. Build and instance word. There is callback. This is scope. Come on, save it. Yeah, the information was there, but it wasn't showing it.
yeah.
I don't know why. Yeah, it's there, but sometimes it doesn't show it. It's very weird.
It's a bug or something.
Yeah, it's a bug. It's definitely a bug in our main activity. We update the list when we open the app. When do we do that? Look, we have a recycler view. We don't have the cursor anymore. We don't need it. Don't need these. Don't need this. Don't need this. Don't need it. Swipe, refresh layout. Update the list. In the beginning, we are updating the list. Let's see if we are doing it correctly. We are accessing the database with our AppDB. We get all of the information. All right. We then set it here as our data to our list adapter. We specify the layout manager, its adapter, and click listener. We might solve it by adding update list to our onResume method. We also have onResume in our main activity. Every activity also has this method, onResume. Update list. This might help us and solve the issue. Because when you, for example, receive a call in your phone, you are inside an application and you receive a call. Then the application goes to the goes to the pause state, unpaused, okay?
Yeah.
And then after you made a call and return to your activity, you resume your activity, which means onResume method is called. some new member, Matt 1212. Yeah, now it's working.
Yeah.
It's adding the new members. Some Ben. It just works when it wants to, you know.
Yeah.
It's not under our control. Okay, I will look into this bug. This is definitely a bug, and we need to find out what the problem is, where the problem is. But note that if you want to review the steps to creating a room database, it's not very difficult. You add a database file that has to be preceded with the database annotation. You see this?
Yeah.
It has to have this annotation. It has to be abstract, and it has to have an abstract method that returns a DAO. And DAO was an object that we use to access our database and our tables. For example, if we have a table for contact, we need a DAO for it to do operations on that table. We have a contact with these fields, and it has to be preceded with the entity annotation. This is important, which specifies also the table name. And we have a DAO for that table. You see, we have a DAO that does, for example, query that table, gets information from that table, and adds some information to that table. So that's it for room. And just with this knowledge, you can add room support to your applications and you don't have to work with SQLite directly. Room will do all that for you behind the scenes. And as you saw in the main activity or any other activity that you wanted to access your database, you simply call room.databaseBuilder and you create an instance of your database. And if you wanted to go further and create optimal database, you can add a method, you can add a static method to your database. And this is optional, you don't have to. But if you wanted to make your database better, you add this part, you add a method getInstance that create an instance of your database. This method seems a little bit complicated, but all it does, in fact, is checking first to see if the instance is already initiated. If it's instantiated, it returns it. If it's not, then it creates it and returns it. Just as simple as that.
Yeah.
So any questions so far?
No, not really.
All right. So that's it for room. I hope you enjoyed this lecture.
Yeah, thank you.
You're welcome. Now we will finish this lecture, but we will have a short talk after I stop the recording about our future lecture.